Hello and welcome to SAE Tomorrow Today. I am your host, Grayson Brulte. On today's episode, we're absolutely honored to have Raquel Erdison, founder and CEO of Wabi. On today's episode, we discuss Wabi's AI-first approach to autonomy. We hope you enjoy this episode. Raquel, welcome to the podcast.
Thank you. Really a pleasure to be here.
We're really excited to have you here because Wabi's building the future of autonomy, and you're doing it through an AI-first approach, and I have to congratulate you because you're onto something really special there. And to kick things off, I'd love to know, how did you first become interested in AI?
Yeah, so I was an undergrad where in one of the classes I got exposed to do my first research project, and it was related to AI. And from that moment, it became very clear that my passion was on learning more about this. And from the perspective of it was very, very interesting, and at the same time, it was something that potentially had the ability to change the world. And therefore, I started working on this. This is almost 25 years ago.
If you weren't exposed to AI as an undergrad, what do you think you'd be doing?
I think I will be doing one of two things. Either I will be a sports person, which I love, or I will be in some other form of engineering or mathematics, something related to math, which I really love as well.
So you love basketball. You're based in Toronto, an executive for the Toronto Raptors, perhaps?
Definitely a fan.
As I mentioned earlier, you're taking this AI-first approach. You founded Wabi. Why Wabi? Why now? Did you see something in the market that now is the time to go?
The way to think about it is, since the DARPA challenge has been, almost 2 decades, right? And there has been meaningful progress. But when it comes to commercialization, we are really far from having a solution that can be deployed at a scale. Instead, you see, very simple operation domains and also very small. And in my opinion, the root cause of this is really the technology that is employed to try to solve this problem. And, I believe that there is a need for a new generation, something different. And the best way to build, a new generation of technology is actually to start afresh a new company. And that's why I founded Wabi a little bit over a year ago.
Will your AI first approach, will that allow you to have a larger ODD where you look at your individuals operating in the field today, either from the passenger side or from the trucking side, they're operating in very small ODDs because of the mapping and the technology? Will your technology allow you to have larger ODDs?
The way to think about it is that, first of all, as it relates to the brain of the self-driving vehicle that basically has to drive it safely, right, from point A to point B, there is a lot of possible things that self-driving vehicle might be exposed to that it needs to react to. And, for current systems, they cannot handle, the diversity and difficulty of all the corner cases, right? So they have to limit the operation domain to something that is simpler, that is more constrained, right? And from that to the, being able to develop, to deploy this, everywhere, there is a big step change in terms of the difficulty and the number of scenarios that they need to handle. So that's where the technological barrier is our current approaches, something that is going to scale, that is going to be able to generalize to all those situations. And, I don't think so. And my experience in the industry has been that, development is very slow, progress is very slow, and we need something different, something that is rooted in automation, that really makes humans really efficient and makes also solutions to be much more built to scale from day one. And that's why, Wabi exists in the first place.
I'm going to put my economic hat here on. Society globally. We're preparing for a pretty bad recession. The development of this technology, as you clearly stated, is slow. They're having issues raising capital to continue this. What are your thoughts on the consolidation? And will Wabi stand out because you're creating that AI brain that you'll be able to scale faster? Say, oh, wait, the market's now in our favor.
Yeah, so I think that, consolidation is not always good. And in particular, consolidation is not good when the solution to what you're trying to solve is not there, right? You put all your bets on a single direction. Chances are, right, for such a difficult problem that maybe you don't get there, right? So we need to be able to look at this problem with, bring many different solutions. And I think that's, one of the problems of the industry. Now, in order to cut through the noise, right, you need to be able to have a differentiated approach. And speaking of the market, so investors really understand that, they've seen the evolution of self-driving. They've seen promises that are not yet there, and it doesn't look like they're going to get there very soon, right? So they understand that it's a need for something else. And they are very excited about what, this next generation that Wabi is providing. And if you look at innovation in self-driving, the thing that really comes to mind is, okay, Wabi is the one. And it's, providing a safer, faster, and much more cost-effective solution that is built to scale. So that's very, very attractive for potential investors, regardless of how good or bad the market is, today.
Is that what your investors at Closer Ventures, they're very bullish on you. You recently did a podcast with them. They say, okay, Raquel, this is the way forward. You cracked it. Is that what kind of drove them to become so bullish on their investment in Wabi?
Yeah, so Khosla Ventures, they are big believers into what we are doing. And if you look at, Sven, who is the partner that we work with, he actually was the lead engineer in, the Stanford car, right? So he actually understands really well why the current solutions or the hand engineer solutions are not really the way to get there. And, for him, seeing Wabi and seeing, our technological approach, he is, so excited about what we are building. And, one of the things, for those of the audience that, are interested, I absolutely recommend to watch that podcast. And you can really see, how we are marching together, towards that goal of really building this technology and bringing this technology to market. And it's going to take time, and Khosla Ventures understands that. But it's definitely going to be there at the scale. And that's, very, very excited. And for those entrepreneurs or the people that are thinking to be entrepreneurs in the audience here, it's very, very important that you choose your investors that are going to be supportive. It's not just about the money, it's about who is going to help you build the best company going forward. And Khosla is amazing. I call them the Ferrari of deep tech.
Khosla has an incredible track record. They've made great returns for their LPs, but they care about founders, and that's a reputation from multiple founders that I've known that have raised money from Khosla. So I have a lot of respect for what Khosla is doing. For our listeners that are interested in the podcast that Raquel did with Khosla, it is available on techcrunch.com. And I want to dive into the current solutions. Raquel, you wrote a really eye-opening LinkedIn post on January 31st, 2022. It seems like it was just the beginning of the year. It seems like a long time, but time flies. And you say the following in that post. First, it's clear to me that AI and automation need to play a more central role. The widely adopted hand-engineered approach to self-driving translates into a software stack that requires constant manual tuning and is difficult to develop and maintain. Not to mention, it requires very large teams and lots of capital. We need to evolve beyond this method and lean in on AI. Is that what you're doing at Wabi?
Yeah, exactly. It's having an AI-first approach to both the brain of the self-driving vehicle as well as the way that we test it through our simulator, which is the other piece that is another AI system. So definitely, I stand by those words. And there is AI in these hand engineering approaches, but AI is utilized to solve small sub-problems within the complex software stack. And in my opinion, we need to really bring AI to the forefront. We need to really build everything rooted on that automation, and that enable us to think about, a set of software stacks that are much more exciting, that have much more power to generalize to those rare cases that we were just talking about before, as well as through, different geographies and operation domains.
How about on edge cases? So give you an example. So some parts of the country, the crosswalks are marked. Certain parts of the country, they're not marked. Does the AI allow you to kind of learn how different crosswalks are in different, let's say, geographical environments?
So the way to think about our AI system is that, through this new generation of algorithms that, proprietary algorithms that we develop at Wabi, which are a combination of deep learning, probabilistic inference, and complex optimization, it enables the system to create intermediate representations that are very good for generalizing to things that it hasn't seen before. So you can actually learn from a small amount of data compared to this thought of AI needs billions of examples in order to be able to do simple tasks. So that's very important in terms of what is the kind of technology that goes within our brain. It's not simply applying AI, it's a new generation that precisely has those nice characteristics that are required for self-driving. And the other bit that is important is about how do you expose the self-driving vehicle, right, the brain to those rare cases. In the industry, typically you need to drive millions of miles to kind of understand where your issues are, right, in the real world, and that's very expensive, and it's definitely not the safest solution, right? And it really doesn't scale. As if the brain gets better, then you need more and more of those miles, right, at some point billions of miles to be able to see issues. So instead, through this breakthrough simulator that we have, we can create those rare cases. We can even, have an AI system play against another in order to really understand what are the corner cases or the difficult cases for your brain, not a general brain. And that's, kind of the next, in my opinion, the next generation of what you need to do in order to really be super efficient, effective in understanding your mistakes automatically.
The simulator is called Wobbly Worlds, and what you described to me, first thing goes through my head is a chess match. Are you teaching the vehicles how to play chess 3-4 moves ahead of what possibly could happen?
Yeah, that's a pretty good analogy, I will say. And I will say maybe game of Go, because self-driving is more difficult than chess. Chess you can do enumeration, right? That's some of the things that we learned with Deep Blue, I guess, a couple of decades ago. But for Go, it's not possible, right? So for self-driving, you cannot just enumerate. This is why we need more sophisticated technology. But that's a good analogy, is that by experiencing the environment, the simulator, we can learn automatically into how to behave and handle more and more difficult situations.
Wobbly World reminds me of Wayne's World, Mike Myers and Dana Carvey. So I like the name. So well done on that. How would you describe it to a listener? Because Wayne's World's a TV show, which became a movie based on a TV show. Wobbly World's a simulator. And then if somebody says, simulator, that's Sim City. How would you describe Wobbly World to a listener?
So probably the simplest way to think about it is, it's the most scalable, high-fidelity closed-loop simulator to ever exist. And by closed-loop simulator, what it means is that you can think of it as a difference between watching a video versus a video game, right? When you are in a video game, you react to the world and the world reacts to you, right? So Wobbly World is a little bit the same, think of it as an alternative world that looks like reality, but it's virtual, right? It lives in the cloud, where the self-driving vehicle can, clone itself, right? And then do in parallel all these different tests and learn from how it's behaving and doing in all those different tests. And, and this, happens, automatically at the scale. So, we like to think about it as the ultimate school for self-driving vehicles, right? Where the instructor, which is Wobbly World, provides scenarios and things that the Wobbly driver, right, our brain needs to do. And then it learns by, the teacher tells, how well or bad it's doing, and this teacher is the AI system, right? And then it learns from that to become better and better and better. And then the teacher can be, very nice and have, simpler scenarios, or can be a little bit more naughty and really understand and poke into, you are not doing this well. Let me bring you a scenario where probably you're going to have more difficulty. And that's how automatically we discover mistakes and issues in the software stack.
Bringing this back to the real world. Okay, so you're 15 years old, 16 years old. You got your learner's permit going. You're going to driving school. Let's do a 3-point turn. Let's learn how to parallel park. And then you can go for your driving test, eventually graduate and get your driver's license. Am I oversimplifying Wobbly, or is it very similar to how a human would go through learning how to drive?
I think the analogy actually goes really well here. The difference is that, as a human, we have incredible capabilities to generalize. But systems like, whether it's AI systems or, just hand-engineered systems, we cannot just trust them. We need to test that they are actually able to do all those things. So the kind of exams that they have to pass are much more comprehensive than what humans, we do, where typically you have 1 hour of exam and that's about it, right? You get your permit. Here is, you have full coverage of what are the sets of scenarios that might happen in the operation domain where you're going to graduate to operate, right? And then you have, a full suite of tests that, you need to pass and do the right thing. But it's a good analogy. I mean, it goes pretty well for what's happening here.
What would be an example of an exam? Is it if you're, for example, a truck is coming onto an on-ramp, can it properly merge at 55 miles an hour? Is that an example of an exam, or does it go more in depth than that?
Yeah, so that will be kind of a scenario type, right? And then you have variations of how those could happen, right? What is the traffic that you're trying to merge to? What is the speed that you're having? What is the appearance, the weather, and the characteristics of the scenario in front of you, right? Because that might fool your perception system. So think about, all the different things that might happen, and then test all the set of capabilities, not just going on an off-ramp. There's different on-ramps, right? At the same time, there is, you have to be able to, pass vehicles properly, stop if there is a hazard, etc., 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 right? So you have to have, all that comprehensive set of all possible tests that might happen in the world. And it's geography dependent, right? In the sense that if your OD doesn't have, for example, a traffic light, you don't need to test for your behavior on traffic lights, right? So that's why it really depends on where you are operating in the world.
Give me an example. I don't know the statistic. It's probably a NHTSA statistic or state DOT. When tires blow out, if there's a scenario, either the truck tire blows out or a passenger vehicle tire blows out, do you train for those edge cases since they are something that happens on the roadways?
Yeah, so in general, you need to be able to react when the behavior of, say, the actors around you is not the canonical behavior. They're doing something that is odd. And whether it is because there is a tire that blew up, or they are sleepy, they are drunk, there is many situations that might happen, right? And as part of your test, you need to be able to say that, even when they are acting erratically or differently, you still need to be able to drive safely. So yes, this is part of the comprehensive set of tests that we do within Wabi World.
Going back to the video games, the PlayStations, they have the little steering wheel that you can do. Do you have employees that just do the stupidest, craziest things, and you import it and say, this is what a crazy person would do, and you kind of learn from that? Or is it a pre-existing data set? Where do you get it's called bad driving behavior data from?
Yeah. So we don't necessarily have the employees playing video games. Although if they're listening to this podcast, maybe this is the next thing they're going to ask. But think about it as it's a combination of learning from good drivers, right? From real drivers that we can learn utilizing real data, as well as learning by acting, right? Meaning that you do something, and we have the teacher, which is an AI system, can grade you, right? And, here you have done something wrong. You should have maybe decelerate and go behind this vehicle. It will have been more safe. Or you should have a bigger distance, right? Because you're driving, too close, maybe, and perhaps, if something happened, that might result in a not so safe situation. Or maybe you are weaving, right, and that's not a great, comfort, as you're driving around the road, etc. So there is many, I guess, nuisance criteria, right, that the teacher uses in order to tell our software stack what is doing well versus not. And from that, then it learns to kind of maximize the score that the teacher tells, how well he or she is doing.
Look at learning scenarios. So you have truck A that's in Wabi World, and you have truck B. So truck A has the traditional hardware stack, and then truck B, you modify it. Do you run that truck with a new modified sensor layout through the system as well and say, okay, do you kind of compare them to try and learn the optimal way to how to configure the hardware on the vehicle?
I think it's maybe useful to give, for context to the audience, how typically hardware and software work, in self-driving, and then I can answer your question. So if you look at, typically the iteration is that the hardware team goes on a silo and develops a new generation of, hardware platform, including new sensor configuration. Then they build it. Then they drop it in the real world and say, software team, now go take this and then make it to work with the software and then validate. Right. So, and then the software team comes back into, oops, maybe, we should have done this differently. I can see issues in this type of scenarios or things. Right. And then you continue iterating this. And every one of these iterations is typically a year and a half, 2 years. Right. So this is very, very costly. This is not the best way to develop. In our simulator, and I the audience is interested, you can see videos of what I'm going to say in our blog. We can test hardware configurations before they ever exist. You can modify the sensors in that simulator, where they are placed, how they are seeing the scene, and then simulate at the scale and train the software stack as if that was their sensors, right? Their eyes and ears, etc. And then test, and give you a report of how well will that system actually behave in the real world in a way that is very realistic, that really correlates with the real world. And then we can optimize for that placement and the sensors such that we are as optimal as possible in how well it will behave. Right, so what happens with this is that now software and hardware are together in this development cycle in the simulator before you build anything. Right, so by the time you decide which one is the optimal one, then you actually just build it and you need very small validation. So this means that you can actually do these iterations of hardware and software super, super fast compared to the year and a half or 2 years that you typically see in the industry. And this is, really a big piece, very important for how fast we can develop this technology and why, our simulator can really enable many, many things beyond what you see out there.
It's a game-changing approach because if you look at the current economic environment, you're able to move faster, and just from what I gather, I've never seen your financials, it seems more economically efficient than having to go through the iteration processes from a labor and hardware perspective.
That's right. And also, you don't need the large fleets to validate that other companies need, and all those millions of miles in the road that are actually, extremely cost inefficient, right? So yes, it's a much faster approach. You can also develop this with with a much smaller team and, in a much safer way because, everything is tested on the simulator and then you need to validate with a much smaller number of miles. So we're really inverting, the pyramid of development right now in the industry.
You're taking the lean approach. Toyota was very famous for the lean manufacturing. You're taking what's called a lean development approach. Do you feel that that's one of your company's advantages, strategic advantages for that AI first approach of being lean and being, I'll use the word, you're as a CEO, you're doing a really good job of cost management?
Yeah. So definitely this is one of our advantages. So, we are much more lean. Also, we are faster, and from the perspective of the developer, it's much less frustrating. Typically, if you talk to any engineer in the industry, that's the first thing that they say is like, it's so slow to make a change. It's so slow to see, whether what I'm doing actually is going to have an impact versus not. It's so hard to understand what is the next step that I need to do. By bringing automation, all that, through your tooling, all that is resolved, right? So it's also much more exciting to be, within this process. But faster, safer, cheaper. That's what Wabi provides. Yes.
It's the right decision for the economic environment, but it's the right decision for your company. And Vivian Sun, who's on your team, is a wonderful person, and she speaks the world of you and what you're developing at Wabi. So Vivian, thanks for turning me on to Wabi. You're an incredible individual. In the future, do you think that more companies will take this AI first approach to autonomy?
Yeah. And maybe a comment about Vivian, who is our Chief Commercial Officer, Vivian Sun, an amazing powerhouse female leader. So I'm so glad and happy to have her in the team. So I think so. I think absolutely. I think it's very, very exciting and approach both together, the approach to the brain as well as the simulator. This will work very nicely in terms of other applications of autonomy, from warehouse robotics to drones to last mile delivery to passenger cars, robot taxis, you name it. Definitely could be extended to those use cases, and I think we will see more attempts to this. Wabi is doing self-driving trucks and tackling the logistic problem, which we all suffer from these days, right? It's definitely on top of mind for everybody. And one day in the future, once we solve logistics, I guess we will go to other use cases. But yeah, I will definitely. I think there will be more approaches or more companies that will try to do this in the next couple of years. Yeah.
It's really interesting. So you look at trucks, and during the pandemic, it's trucks with e-commerce was booming, but actually e-commerce is slowing down now. Retail in person is starting to pick up tremendously. We saw it in the Costco numbers. And the trucks go to Costco. They're bringing pallets of all sorts of interesting things to Costco. Why trucks first? What did you see in the market? Was it the economic opportunity? Was it the growth opportunity? What did you see say, okay, we're going to focus on trucks first?
There is a couple of reasons for this. First is you need to go to a business where there is an absolute need for the technology that you're bringing, right? And it's clear that I think by now everybody will agree that the supply chain is actually broken, and that we need a solution that will enable us to really move loads, across country or across the country, in a much better way, right? So, and there is a chronic shortage of drivers, and this is getting worse and worse, as time passes, right? So, automation, a couple of years ago, my thing was nice to have. Now is like cure from cancer, right? Is you absolutely need this for logistics. The other side of the coin is that when you think about the operation domain, the difficulty of the task, right? So self-driving trucks are going to drive mostly on highways where it's easier to drive than, robot taxis in cities, where, for example, the task of picking up a passenger is not obvious to me how you're going to do this, because, most of the times people do this by parking illegally. And that's not something you're going to enable your self-driving vehicles to do, right? So there is a whole bunch of, issues already on that, one little piece, right? So, simpler, I will say, in terms of the technology perspective, very clear use case, and the economics just work really, really nice, right? Where, a truck is also, typically a truck is $250,000. So you can have a sensor configuration that, might be a little bit more expensive, right? But, with a little bit of utilization, right? Since you're going to be able to utilize it 22, 23, 24 hours a day, yes, they work really, really nice economics, right? So altogether makes a clear use case, in my opinion, for trucks. Plus, I love trucks in the first place.
Trucks are cool. You're not going to have cars on the highway are not going to double park. I mean, you might if you're in LA, you're going to get a traffic jam, but they're not going to double park there and move in and out of buildings. You love trucks. I love trucks. My grandfather had a CB radio, and we played the CB radio game, which was kind of fun. And then we heard some vulgar language, and we got our CB radio taken away. But the one thing we didn't get taken was the honk game. When you go honk, honk with the arm, will you eventually teach your trucks how to play the honk game? Because as a kid, I loved the honk game.
That's an interesting question. Let's see what the regulators think that it should be the answer to that question. But definitely you could do things like this, yes.
It'd be great. You can encourage children to grow up and develop new technologies because they are able to play the honk game with an autonomous truck. It's good for society. It makes a long road trip that's boring fun. When trucks go hundreds of miles, thousands of miles from coast to coast, how do you create Wabi World where you're going to operate that? Do you drive a car from coast to coast and build the world around that? Or how do you go about creating Wabi World since trucks go on long stretches of road? Yeah.
So, I think one thing that is important is that you don't need to recreate the entire world in order to be able to drive in the world everywhere, right? You need to be able to have, the diversity of the things that might happen on those different geographies, right, within your simulator, right? But that doesn't mean that every single mile has to be part of your test. Otherwise, your computation will be unbounded as you go, bigger and bigger, right? So, but if you wanted to, the way that you will do it with Wabi World is that you need to drive once, and then automatically that becomes part of the simulation. And that doesn't need to be a truck. You can drive with a car or any other platform that has cameras and lidar. That's the only constraint. And given this, we can simulate anything that you have seen, every actor, and then place them to do all different things that never happen in the world, right? So that's a super scalable solution, right? That is definitely beyond what you typically see in the industries that humans, artists, create every asset, right? And then there is a little bit of automation to create some scenarios from that. For us, it's just through AI, we can, digital twin everything you have ever seen.
You're building the Unreal Engine. That's a video game term that Epic Games built. Is that really what you're building? You're building a high-end video game that's alive?
I think one way to think about it is like the Unreal Engine on steroids for self-driving. So it's a good analogy, but the technology behind is very, very different from, I would say, what the Unreal Engine actually utilizes. But it's something where you need to simulate or be able to create all possible scenarios that might happen. You need to be able to score those scenarios in a way that really tells you whether you're doing the right thing, and that's actually pretty difficult, right? It's not just don't crash, right? It's, driving is much more nuisance than that. You need to be able in real time to simulate how the sensors will have observed the scene, whether it's cameras, radar, etc. And you need to be able, as I mentioned before, to play adversary so that you understand the potential mistakes quickly of what your software stack might fail, right? So there is a lot more functionalities and things that you will see in an Unreal Engine, and we don't use Unreal Engine. It's something very different. But I would say it's a good analogy for those that have seen maybe some videos or have played with Unreal.
I like video games. I think you're picking up on that. How often is Wabi World updated? Is it when you run different scenarios through Wabi World, or how does the updating work?
Yeah, so Wabi World can continuously generate new things. So it depends what you mean by update. So create an unbounded number of scenarios. So in that sense, it can be updated, and in parallel, all the time. In terms of adding new maybe actors or things that look or part of the environment in 3D, then you can, every time that you drive one of these platforms right on the real world, everything can be imported in the simulator, right? So that's, it can be as big as, you want to, right? But what is important is that you don't want to also, grow to scale and then have everything, right? Because then, you will be just doing computation all the time, right? It's very important that you also have the smarts into what should I run when. And this is where the other piece of automation is very, very important. Versus have humans decide, should I include this versus not? Well, humans don't really necessarily understand. But through AI, we can understand what is the best kind of combination of things that we should add. Where do we have something missing in our coverage? Then let's add that, etc. Right? And that's the way that we continue to add things to the simulator.
From an environmental perspective, can you add rain, hail, wind, different weather elements in there as well?
Yeah, so I can talk a little bit maybe of how the actual sensor simulation works. So typically, traditionally in the industry, it will be a physics-based simulator where you run these complex simulations, and if you want it to be very realistic, typically it's very computationally expensive. And also it requires you to know everything about the environment, the material properties, the light environment, and all sorts of things that is actually really, really hard to estimate in the first place. Typically it's impossible to do that. So for our approach, we use a combination of AI and physics, where physics here is going to be a simplified physics that is easier, faster, and then AI makes that simulation to be much more realistic. And this enables us to be super fast and simulate complex things, like illumination you were mentioning before is one example. So it's a very different way to do simulation compared to what you will see typically.
I'm going to put on my random pop culture hat, but this reminds me of the early founding days of Lucasfilm. When they started doing all these different techniques, they did techniques for sound, they did techniques on how to shoot it, how to build digital graphics up at Skywalker Ranch. It sounds like that's what you're building. You're building the next generation of Lucasfilm.
I don't know about that, but sounds cool what you're saying.
George Lucas, Star Wars. So there you go. So you're taking us to a planet far, far away. You have this great background in AI. AI is a hot topic. You turn on the news, you hear AI, you hear it in the stock market. What are your thoughts on the future of AI?
Yeah, I think the future is very exciting and bright. I think that, but for it to happen is not with the AI that we have today that we're going to solve all the problems of the future. there is a lot of new AI that needs to be developed to tackle some of the complex problems. And then we need to responsibly develop and deploy those AI systems in the world. But for me, I think it's extremely exciting. We have just touched I would say what AI can really do for us, and I look forward to see that future because, as I said, there is so many things where AI can really help humans.
Are we merely at the tip off at the first quarter using a basketball analogy, or where would you, using a basketball game, how would you say we are in the AI calendar?
Yeah, I would say that is hard to say, but there is whether it's first quarter, second quarter, probably it's definitely the first half, and there is many things still to come, both from the technology itself, right, as well as from the use case into it can transform every single industry, and we only are starting to see small little pieces here. The one thing that I think is interesting also to make the analogy to self-driving is that, oftentimes, or people in self-driving think that AI is there, and if you use current techniques, then you will be able to solve self-driving. But that's not the case. You need these new generations, new algorithms that really go beyond, that are built to scale, that are really bringing a totally different view of, this traditional problem that we've been trying to solve for 2 decades, right? So that's the kind of thing that we need in more industries. And I think there is some amazing innovators out there that will be able to bring this, for example, to medicine, right? Where I think we will all argue that is one of the most important bits right now.
I would summarize it this way: AI will have an extremely positive impact on society. Putting this conversation into context and diving back to self-driving, what is the future of Wabi?
Yeah, I think the future of Wabi is extremely exciting. We talk about the simulator that we have seen, but I can't wait to see all our trucks driving on the road at the scale everywhere, bringing, removing the problem of supply chain. So that's, the future for me, and that's just the beginning. There is so many more things, and self-driving for me personally has been an obsession for the past more than 10 years. And particularly safety as well. I think if you look at NHTSA, they just released, I think it was 2 days ago, the crash report where it's been the worst since 1975 in terms of, deaths in the US with 43,000, right? And I guess, I can't wait to see safer roads. And I hope that, definitely what we will have a big contribution to increase safety in our roads.
Autonomy will make our roads safer. Wabi and your peers in the self-driving trucking industry will help unclog the supply chain, which will have a positive impact on this big bad monster called inflation and drive it down. Raquel, and as we look to wrap up this super insightful conversation, what would you like our listeners to take away with them today?
Yeah, I think that, self-driving is, one of the most exciting problems of our generation, and it's going to happen. Like I promise you, it's going to happen, and it's going to happen, relatively soon, right? And I think that what we just need is different technology. And yes, for those that are excited about AI, there is an incredible young generation out there, particularly women. We are waiting for your collective brain to solve this problem. So come join us. The future is extremely bright and exciting.
The future is extremely bright. It is going to happen. We will have self-driving because today is tomorrow, tomorrow is today, and the future is Wabi. Raquel, thank you so much for coming on SAE Tomorrow Today.
Thank you. My pleasure.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we speak with the founder of the Barnes Global Advisors about how companies can decrease production costs and reduce energy consumption through additive manufacturing.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.